Welcome to my talk. My name is Soroush, and this work is a system that we created for preventing extension fingerprinting. And this is a collaboration between Arizona State University and the University of Illinois at Chicago. Browser extensions are small programs that users install to add some new functionalities to their browser. But websites might be able to find a way to detect the presence of these extensions in the browser. And then they might be able to use the list of installed extensions to reveal some sensitive information. For example, the religion of the user or ethnicity of the user. There are multiple different approaches that websites can use. One of them is DOM-based approach. In the DOM-based approach, extensions make some modification to the page. For example, LastPass injects an icon to the page. So the website can observe that modification, and based on that, it can detect these installed extensions. In this work, we want to create a system that can prevent this type of extension fingerprinting. Extensions make some modification to the DOM tree. So the websites might have some scripts that can observe those modifications. So the root cause of this problem is the DOM object that is shared between extensions and websites. So our solution is to kind of separate the DOM that is accessible by a website and the DOM which is observable by extensions. So we create a parallel DOM, and this parallel DOM can be accessed by the web scripts. The web script can read everything from the parallel DOM, and the parallel DOM doesn't have the extension fingerprints. The extension fingerprints, the extension behaviors will be applied on the user DOM. So the website cannot observe those fingerprints in this scenario, in this case. To be more specific, if there is a read function, that read function will be executed on the parallel DOM. So if website wants to call an API which returns something, that will be executed on the parallel DOM. And if the website wants to make a modification to the DOM, that modification will be applied on both two DOMs. So we will have the same modification on both two DOMs to keep the parallel DOM synchronized with the user DOM. The design of this system has too many details. I'm just going to provide some overview of the design of this system. What we do in this system is intercepting the DOM interacting APIs, and we run those APIs on the DOM that we want. And using this approach, we want to hide those fingerprints. So we need to categorize the functions, and based on the functionality of those functions, we need to change the behavior that they need to have. So let's see the first category of these functions. The first one is this category is the list of functions that read something from the DOM. Let's see a scenario that there is an extension which makes a modification to the DOM. If the website can call a function that can get access to this element, the website can observe the extension fingerprint. So we want to run that function on the parallel DOM. So what we do is overriding this function, and we change the receiver of that function. So it will be executed on the parallel DOM, and it can hide the fingerprint of this extension. The second category of functions are the write function, those functions that make a change in the DOM. If a website wants to add a new element to the page or do modifications like that, we have to apply this modification on both two DOMs. So first I execute that function on the parallel DOM, And then we find the equivalent one on the user DOM to run the same thing here as well. So we will have the same modification on both two DOMs. This was the second category. The next category of functions are those functions that cannot be executed on the parallel DOM. For example, active element. This is a function that returns the element that user has focus on. The parallel DOM is out of focus. It is on the background, so we cannot run this function on the parallel DOM. What we do in our system is running this function on the user DOM, and then we return the equivalent of this element. We return the equivalent of the element that is active. So we prevent, we hide the fingerprint of extensions in this way. And the last category actually is about the functions that don't return anything or don't change the DOM. For example, we have a play function for video elements. So using this function, we can play a video, but it doesn't change the DOM or it doesn't return anything. For these type of functions, we can just run those functions on the user DOM. So these functions are those functions that are DOM interacting APIs. There are some other functions there are some other APIs like performance API or permission API. They don't have any DOM interactions. We need to we need to ignore those APIs. For finding those functions that are DOM interacting, we created a system to automate the process. So we intercept all API calls, and we look at the argument of those functions, the receiver of those functions, and return values. And if they are something DOM related, then we flag that function as a DOM interacting API. For example, this is the result of our system on CNN.com. The highlighted interfaces are those interfaces that are DOM interacting. So we need to override these ones, and we can skip the rest. We use our system to analyze the top 10,000 websites, and we found that there are more than 1,500 functions that we need to override to create this system. For our idea, we created a prototype, which is an extension, and we call it Simulacrum. Simulacrum starts at the beginning of a page, and it overrides all those functions that I mentioned before. After the overriding process, browser starts to parse the HTML code and generate the DOM. So when the DOM generation was completed, Simulacrum make a copy of the user DOM to generate the parallel DOM. From this point, we can hide all those extension fingerprints. And now let's see some evaluations of this work. The first evaluation is about the effectiveness of this system. So we used Karami, which was the state-of-the-art for detecting extensions based on the DOM modifications. And by using Simulacrum, we were able to protect more than 95% of extensions. And most of those extensions that we cannot protect are those extensions that make the modifications before we generate the parallel DOM. So while the browser is parsing HTML code to generate the parallel to generate the DOM, they make the modifications. So we cannot hide those fingerprints. And to evaluate the impact of our solution on the user experience, we manually analyzed 50 popular websites. We decided to analyze the popular websites because they are more complicated and they are using lots of different APIs. And we saw that there are 12% of websites that have at least one functionality that are broken. And we also saw that our system has some minor issues for 10% of websites. As a conclusion, DOM-based fingerprinting is a very hard problem to find a solution for. And we introduced DOM reality shifting idea to prevent this type of fingerprinting, and we create a parallel DOM for this purpose. For this idea, we created a prototype, and we saw that it can protect more than 95% of extensions that are fingerprintable by kernels. And also, we made our system open source, and we hope that this system can be used in other projects for preventing other privacy issues. Thank you so much. I would be happy to answer questions.